Hello everyone, welcome to SCI-EASE. In this video, I am going to take up the last topic of this chapter, and the topic is power of a lens. What do you mean by this term power? The power of a lens is a measure of a degree of convergence or divergence of the light rays falling on it. Okay? Power of a lens, that depends upon the focal length. So, the definition for the power is, the power of a lens is defined as the reciprocal of its focal length. What do you mean by reciprocal? 1 by. Okay. So, power of a lens is equal to 1 over focal length of the lens in meters. Focal length of the lens in meters. Why I have mentioned this? It's very important because when you will solve the numericals, you are to convert the focal length into meters first, and then the answer that will be there. So, this power that is denoted by capital P, and focal length you know that it is denoted by small f. So, P is equal to 1 by f, where P is the power of the lens. Therefore, lens of short focal length, because it is inversely proportional, so the lens of short focal length will have more power, or vice versa. Means a lens of long focal length has less power. Okay? I think this thing must be clear to all of you. P is equal to 1 by f. This is the expression which is used to calculate power in the numericals. Okay. The lens having the short focal length, it has more power, and the lens having the long focal length has less power. This you should remember. Each and every word that is important. Now, what are the SI units of power? SI units of power is diopter. You must see the spelling D-I-O-P-T-R-E, and it is denoted by capital D. 1 diopter, it is the power of the lens whose focal length is 1 meter. So, 1D, it is equal to 1 meter inverse. Okay? So, one thing which is very important, and you should remember this, the power of convex lens. The power of convex lens is always positive, and the power of concave lens is negative. When you are to solve the numericals, these things you must keep in your mind. The expression for the power, that is P is equal to 1 by f, and then I have told you that the focal length should be taken in meters, and the third thing, the power of convex lens is positive and the power of concave lens is negative. Now we will solve one numerical based on this power. Now the numerical is, I will read first the statement. This is the question. A person having a myopic eye uses a concave lens. We should see this, that which lens that is used. Concave lens of focal length 50 centimeter. What is the power of the lens? Okay. So, given is focal length. And we know that for the concave lens, focal length is always negative. So, it will be minus 50 centimeter. And I have told you that we are to convert first this centimeter into meter. So this will come out to be minus 50 over 100, 50 over 100 meter, or it is equal to 1 by 2, or it is equal to minus 0.5 meter. So this is the focal length of the concave lens in meters. So first we are to convert it into meters. Now the next thing is we are to calculate power. So P is equal to 1 by F. And what is F? It is 1 by 0.5 minus. Okay. So it will be removing the sign of this decimal sign. It will come out to be 10 by 5, or it is equal to minus 2. Okay, so power that is equal to minus 2 diopter. Must write the units, okay, or you can write it like this, minus 2D. So must write this minus sign because this will tell us that the lens is the concave lens. Okay, when the power it comes out to be positive, this means that the lens that is the convex lens. So such type of the questions they are asked. So with this I have completed this chapter. You are to practice numericals on your own depending upon the formulae used throughout this chapter, on the mirror formula, on the lens formula, magnification, and then this power. Okay, so I will meet you in my next video with some other chapter of class 10th. Till then, thank you very much.